Welcome to all of you in my new video, and in this video we are going to discuss about the velocity time graph. Now in velocity time graph let us consider our object और our body move along the straight line. हम यहाँ ये कंसिडर करके चलते हैं कि हमारी बॉडी जो है स्ट्रेट लाइन में मूव करती है. अगर मेरी बॉडी स्ट्रेट लाइन में मूव करती है तो वेरिएशन जितना भी वेलोसिटी के अंदर वेरिएशन आएगा विद रिस्पेक्ट टू टाइम उसे हम रिप्रेजेंट करते हैं अकॉर्डिंग टू वेलोसिटी टाइम ग्राफ. इन वेलोसिटी टाइम ग्राफ we represent our time on x-axis and the velocity on y-axis. Now in this velocity time graph we have three cases. First is when your object or the body move with a uniform velocity. When your object moves with a uniform velocity, and case 2 when your object moves is in motion with uniform acceleration, and third case when our object moves with non-uniform acceleration. So first I discuss here first case in which our body can move with uniform velocity. Uniform velocity means the value of the velocity of the object is doesn't change, it remains the same. Magnitude of the velocity and the direction of the velocity remains the same, its values doesn't change. In this case we get a straight line which is parallel to the x-axis. It means if we will try to plot a graph for velocity time, we get a straight line which is parallel to the x-axis. Now I consider at any instant of time t1 and the t2 your object will reach at point A and B. Then I draw a perpendicular from point A on the time axis and the perpendicular from B to second perpendicular from point B on the time axis. Then here we are getting a rectangle. So area of this rectangle represent the displacement or the distance moved by the body. Okay, so now here we will try to find the area of rectangle. You know that the formula of area of rectangle is L into B. Here is a L is the length is represented by AD, and here AD represent the velocity, and the value of velocity is doesn't change. AD and BC values are same, and here CD, this is the difference of the time interval. So I write here T2 minus T1. So product of these two quantities is represent the displacement. So it means in my first case, if I want to find the displacement or the distance moved by the object, we will try to find the area of rectangle under the straight line that we obtained. So it means here we can say that overall we conclude that magnitude of the displacement and the distance moved by object is equal to the area enclosed under the straight line.